I'm Diana Dombrowski with the Sam Proctor Oral History Program here with Suleiman Tufekci. On April 16th, 2014, we're going to talk about the IPPD program. Okay. And I wonder if you could please, before we start talking about the program, tell me a little bit about your educational background and how you came to UF.
Originally, I am from Turkey. I'm a U.S. citizen right now, of course, but the year was 1977. Actually, I'll roll it back, 1971, when I graduated with a BS degree from Middle East Technical University in Ankara, Turkey. That's one of the leading universities, technical universities in Turkey. And 2 years later, I had my master's degree, both in industrial engineering. So in 1973, Georgia Tech accepted me for a PhD program. So I came to Atlanta in 1977. And, I'm sorry, 1973. 71, BS, 73, MS. Now came to Georgia Tech. 1977, I graduated with PhD. And then I stayed 2 years at Georgia Tech as a postdoc scholar. And immediately after that, I have been offered a tenure track position at Syracuse University, Industrial Engineering and Operations Research Department. And I stayed there 2 years, and one of the fellow scientists from University of Florida, which we used to usually meet at conferences, said that the ISC department here at the University of Florida was looking for a faculty. I said, no, I think I'm good. I just got a good raise. I don't think I want to move. He says, okay, why don't I invite you for a seminar? We'll pay for your travel and all that. Just give us a seminar and go. I said, well, that's good. That's fine. Florida, a good place to come. Anyway, I came and I gave a seminar and met a few faculty. And they made me an offer I can't refuse. That was in 1981. When I came to this university, to the Department of Industrial and Systems Engineering. And I've been here ever since, with the same department. I have 2 sons of my own. One is about 32. He's a graduate of Georgia Tech as well, from the same department as I graduated. The other son is about 29. He's a late bloomer, I should say. He's about to graduate from the ECE, Electrical and Computers Engineering Department at University of Florida. And I also have a stepson from my second wife. And he's 22, and he's at Santa Fe Community College. So that's the short life story of mine.
Okay, that sounds good. At the beginning of IPPD, you were part of the task force.
Yes. That
was formed to come to consensus about the program. So could you tell us about that experience, please?
Well, it was, let me try to put it in the context of how this thing started, really. There was a big push by National Science Foundation that our engineering education became stale, sort of like no major pushes were in effect. And we were teaching the same courses, we were using the similar books, but the engineering was changing, the world was changing, and our education had to change to adapt to this new world, if you wish, new technological world. And of course, we also know that the U.S. was losing in industrial competition to China, to Japan, to other countries. And of course, this was driving the need for NSF to revitalize the engineering programs, not only at University of Florida, but all over the U.S. education. So they decided to have some funds available for improving engineering education in the United States. And they built consortiums. And one consortium, actually, we built was Southeastern Conference type of thing, that University of Alabama, University of Florida, a few other universities were one conference. There was one in Midwest, there was one in Northeast, et cetera, et cetera. So they asked us to write pre-proposals to implement, to see how we can improve the engineering education. And in fact, I submitted 3 proposals for this NSF grant action. And one of them, partly I was involved, was the IPPD. And I had yet another one. One of the problems that we had in our department, industrial engineering department, was although we're teaching our students manufacturing process, how to control the production, etc., but we cannot show, or at least have students have the ability to be able to understand what manufacturing means, what machine means. In the olden days, the industrial engineering departments, just like mechanical engineering departments, had machines and machine shops, little laboratories. But the technology was now changing so fast, the equipment that you purchase and put it into your laboratory 2 years later is outdated. Mm-hmm. And it was very hard to replace them. They're expensive equipment. So we realized that it's almost impossible to build those laboratories with the machines in them so that the students can get an experience. So one of the ways that we could do that, I said that maybe I can build emulated factories, simulated if you wish, in just computer world. So that the students can, sit down and as if they're managing a factory, but in the computer world, and make decisions as industrial engineers makes, and so on and so forth. And they liked that idea. The NSF liked the idea. They sponsored it for 2 or 3 years. I don't remember now. But yet IPPD was another one of those. And we said that, look, the engineering world is changing so that it's not just isolated engineering anymore, but it's a teamwork. Engineers have to get together to design, develop, and provide services and products to the customers in a better, faster, and the right way. And that's how the IPPD proposal turned out to be. In other words, we wanted to change this, what we have in engineering is senior design courses. As the senior students, before they graduate, and usually it's either 1 or 2 semester course, they try to find out a real application out in the industry, the business, and 2, 3, 4 friends, 5 friends get together from the same department. And they go study, understand the problem, they come back and try to find a solution, and then make the presentation and saying that, okay, this is what we have, we think it's going to work, and that was the senior design project. But of course, most of these requirements of the corporations, companies, is requiring multiple engineering skills to be applied to the problem. And that was the lack of experience that we had at University of Florida in all the universities, actually. So senior design projects were always senior design projects. It's belonging to a single department. Now we said that we can change this. We can make this a teamwork of different engineers, and the way we select those engineers to a project is based on the project identity, the characteristics of the project. Sometimes it needs 2, 3 mechanical engineers. We will put 2, 3 mechanical engineers. It will need electrical engineer. We will put electrical engineer. It needs industrial engineer. We'll put industrial engineer. So now IPPD program became a joint venture of practically the College of Engineering, except maybe 1 or 2 departments, which is outside of the focus of the IPPD program, such as civil engineering. It's just they have their own world. But mechanical engineering, material science, industrial engineering, chemical engineering, electrical engineering, computer science, just at least 6 of them I already counted. Maybe there are 1 or 2 that I'm missing right now. But all of these can cooperate together on a project. Now, what are the advantages of that is, first of all, of course, they learn the teamwork, participation, leadership, communication skills, and classic things that they were missing a lot on our engineering students. But on top of that, they learn to communicate with each other, understand each other's languages. Because, every profession has its own technological verbiage, if you wish, that other people can't understand. But through this cooperation now, they know how to communicate with each other, and they also understand and appreciate each other's contribution to the overall engineering effort, so that together, the sum of the individuals is actually the teamwork is bigger than the sum of the individuals, and that's the whole thing. Not only that, but they also now know a systematic way to reach to a solution to a problem. First, they learn to listen and understand the customer. And customer could be industry, customer could be us, people like us. And what does the customer want? And how do I translate that customer needs into product specifications? You know, as a customer, for example, if you say that, hey, I want that car to be fast. What is the meaning of fast car? Well, I'm just an ordinary customer. I can't define it any other way. I know, you know, when I see one, a fast car, like 0 to 55 miles an hour. When I drive it, I would know that. But now, as an engineer, it's my responsibility now to convert that need into a specification, a characteristic of the product that I can measure. And in the design of the motor, design of the wheels, design of this, design of that, the size of the engine, I'm trying to drive that capacity of that car so that it can really go to 0 to 55 in seconds. How many seconds? Before you make that decision, you say, okay, I have to look at my competition. And this is what we call benchmarking. Now you have to benchmark your product against all the other products in the same market level. Remember, you're not competing with Lamborghini, for example, if you're a Honda Civic. So it's got to be the similar thing like Toyota Tercel or whatever, you know, the similar characteristic car. Look at them. You can always get them, you can always test them. Find out, you know, what they do in 0 to 55 miles an hour in how many seconds. And you set your target. Say that the design that I'm going to have should beat them. That's fine. That means that in that specific thing the customer wants, you're becoming world class if you can beat them. Sometimes, you know, people will say, the engineer will say, we don't have the technology to be able to be so precise in our cutting and tools and all that. So therefore, we may not be able to afford that. It's going to be too expensive for us. So, well, we'll try to be the second best. Well, at least you know now that you're second best. So all of those things, the verbally the customer expresses as customer needs, we have to, as engineers, translate them into what we call product specifications. Each will have a metric that we can measure, and each will have a target. That in our new design, we're trying to reach to that target. Some targets are smaller the better. For example, customer says, I want a car with minimum noise in it, inside. That's all I say. I don't know what decibel that means. Mm-hmm. Now, it's my job as an engineer saying that, okay, noise, so therefore the measured noise inside the car metric will be decibel. What will be the amount that I'm going to target again? Benchmarking. Find out what the other cars' noise are. If I do best, lower decibel than that, I'm world class again. If I design something that's more than that, I'm beaten again by my competition. So if you answer all these customer needs with the proper target values, and if your new design meets those targets, then obviously that's the best product that you are now about to offer to your customer. So this is what we teach our students. Listen to your stakeholder or customer, let's call it. Translate it into product specification. Next thing now is to design the product. How do you design the product that answers all these specifications you just established? So you have to design prototypes, subsystems, test them, verify them before it becomes a final product and gets into the production line. So all of that is done, is the verification product test. Once you pass all these stages, then comes, okay, what will be the manufacturing system that will support this production? Do I have the equipment? If I don't, which equipment do I need? And how much money do I need to invest there? Capital requirements. And then eventually, of course, when all is said and done, then what's called the production ramp up. You start the production, you check, ensure that everything is doing fine, and eventually get into the full. So our students in this IPPD program learn this whole process, the systematic way of designing and developing a product and its processes. And that's why the name IPPD, Integrated Product and Process Design. So that requires a teamwork, requires production engineers, requires industrial engineers, requires mechanical engineers, requires electrical engineers, requires chemical engineers, all these engineers. So that's what the beauty of it is. And when we started talking to the industry, and the best part of IPPD, of course, is that naturally it is industry-sponsored course, meaning that projects are given by industry and financially sponsored by an industry. So we're talking about real problems and solving real problems of the industry needs. And they loved it. And of course, at the very early beginning, we only had 4 projects. I had 1, and 3 other guys had 3. So that's 4. And the next year, I'm just trying to recall, if I'm lying, just forgive me, but 6 or 8, I'm not quite sure how many it was. And then it started going up to 10, to 12, to 20, to 25. So now, currently, in the last 10 years or so, our average is about 18 to 25 projects each year, year after year after year. We have accumulated enormous number of industrial-sponsored projects. We have graduated over 1,000 students, senior, and these are one of the best students that we have in the College of Engineering. So it just went on and on and on, because the reason for that was that this was one of those beautiful programs that is really win, win, win. Now, who are those 3 wins? Win for the faculty, great experience. Win for the students, great experience, plus they get employment for the company that they got the project for. And of course, a win for the company because their problem is solved. On top of that, they had the choice to look at those students and choose the ones that they need and give them an offer. So it just was a great win. And that's probably why it lasted 20 years and is still going strong.
Yeah,
I'll stop there. I'm a big talker, so
that's great. We prefer that.
Okay.
Definitely. I know that you've graduated. I think the website said over 2,100 students. So
yes,
that's amazing.
Yes, yeah, that's a better number than over 1,000. Yeah,
right. Yeah,
2,100.
exactly.
Yes.
So besides the size of the projects you initially started with, the 3 to 4, then the 20, what are some other differences that you've noticed between when the program began and the way it is now?
The earlier program and the new?
Yeah, differences.
Well, one of the things that, of course, over the years we have learned is scoping the projects. Okay. Because, the success of the project depends on few components. One of them is the scope of the project, that is how big, how wide, and what's involved in the project. And other things are, of course, the right selection of the right students for the project and with their right background, and assigning the right coach that is capable of handling such project, knowledgeable. And of course, certainly, the last thing is ensuring that the industry liaison, we call it, person that's going to be assigned to the project, that will be monitoring, also helping our team, will be truly dedicated to this project and will spare time and allocate time. So, at the earlier phases, of course, we had some projects we didn't have enough support from the industry. There were some projects maybe we didn't compose the team properly. So we did not achieve our optimal performance, perhaps. I would not call them failures, but they were not the best that we could have delivered. But over the years now I have well over 30 projects under my belt only. Most of the time, 2 projects a year. Lately, 1 project a year. But never missed. So 20 years, if it was only 20 projects. But there were some years that I had 2 projects, so it's about 30 or 30 plus. There is a great amount of accumulated experience. I know how to handle my teams much better. I know how to drive them much better. I know how to connect industry and our liaison from the industry to our team much better. And all of that, of course, are a precursor to a success. So when the right brains create the idea, eventually is implemented, it turns out usually to be a success. So it's just all these collective minds of the coaches that are getting together and, feeding each other ideas, feeding each other the success stories as well as the failures, is of course, this accumulated knowledge and experience. So that's the difference, I think. And we can scope definitely the project better, and we can certainly select the right students for the right projects.
That sounds great. What are some of the traditions that you at IPPD routinely go back to year after year? Maybe in the way you select
traditions,
students.
Did you say?
Yeah. Like, do you have any time-honored traditions, the way you celebrate the end of a project, or how you bring students on? Yeah.
Yes, of course. We have, first of all, we introduced, this is different again. You see now, Here is yet another characteristic of IPPD program.
Okay.
Before, the projects are staffed by the students. We have this all get-together, great combination of, I don't know, 150, close to 200 students for that year, and all the projects at hand. Ahead of time, the coaches are assigned based on the characteristics of the project. Now, you're going to be the coach of this project, you're going to be the coach of that project, but we don't have students assigned. So now it's the job of each coach to sell that project to those 150 students and say, okay, prioritize the project that you want to be number one choice, number two choice, number three choice. We'll do the best we can to try to put you into number one, your number one choice. But if that doesn't work out, if too many people are asking for the same project for number one, then at least we'll try to respond to number two, if not one, or number three. In other words, we give you the priority. And then, of course, we go out there, and then it's about 60 seconds is the normal time that I'm supposed to sell my project, my idea, to my future team in that 60-second presentation. So I quickly explain to them what this project will be all about and the kind of engineers that I will be needing. I will need 2 EEs, 1 ME, 1 ISE, 1 this, 1 that. So the students listening, those 150, they have those choice papers in their hands. Says, yeah, I like that. I like that guy too, maybe. And then says, okay, that's number one. And then goes number two. And then immediately after that, again, this is part of the ritual. All the coaches get together and try to see now how we're going to assign students to the project. As I told you, there are some projects that are more popular. For example, a Disney project might be more exciting to students. So, oh, I want to be on the Disney project. So too many people may be saying that I want this to be my number one. When that is the case, you can select, say 2 mechanical engineers, only 2 can be selected. So if there are more number one selections, then we have to make a choice. So the faculty from the department of the student comes together, the director of the IPPD, we're all together saying, okay, so how should we allocate that? Anyway, eventually we try to please all the students to their best assignments that we can have. And that gives them motivation, of course. That, hey, I was able to get into the top 2 choice or top 1 or whatever. So there is more drive there for the students to start with. And then immediately after that, we have our get-together meeting. The faculty coach and the teams meet together. And usually that's the time, what we call the icebreaker. Because, 5, 6, 7 people, never seen each other before, are together and they're going to be form a team and then become a team for the next 8 months. So what we call is an icebreaker, so everybody starts talking about who you are, what you are, and all that, and play little games. And before you know, people start warming up to each other. And if it's going to be a good team with a good team chemistry, it shows itself very early. As another experienced coach, that you can recognize whether the team is already gelling together or they are still acting individuals. And so that's one thing. Of course, at the end of the first semester, there is what we call the system level design report. Again, all of us get together and we invite the industry sponsors and usually make those presentations at Rights Union with the breakfast, the snacks, the lunch, and whatever, all these things. So that is another ritual that we repeat every year. And at the end of the, of course, second semester, we have the final design reviews, where again, we invite all that industry come back. And the students now, they have their things they can display and show them how it works. And they have the videos, they have the whatever, computerized animations, and little snacks here and there. So people can wander around and then look at each and every one of those projects and say, wow, that's awesome. So that's another ritual of ours. So that yeah, we do have some rituals. We continue.
Could you describe a time when one of your students has gained value from the program, or maybe a student that stands out in your memory who really worked hard or had a lot of success on a particular project?
Well, actually, there are plenty of them, so it's not one because
yeah.
I had 30 plus projects. But some students, yes, you can recognize them from early on.
Okay.
They're just born natural leaders, They just emerge as a leader, team leader. And the good part of it is that, they're not just leaders to guide people, but they're there to set the example as well. So they are the hardest workers as well. And when a team gets a great leader like that, usually the performance of the team is lifted up as well. And most of the time, I would say, the result, the product is a great success. And I had several of those. And those fellows got the jobs from the companies that sponsored them. Not only I, but they were able to recognize a good value, and they see one. So immediately, of course, they hooked onto this guy, and then guys, I should say, more than one, different projects, different times. And they hired him just like that, and they were happy to get there and be there. Yes, I have several students that I made a change in their life probably, and they changed their own life as well through this IPPD experience. Otherwise, they would not have had that opportunity. So yes, many of our IPPD projects, sponsoring companies do hire people from that project team if they really need it, of course, personnel. They don't look around anywhere else, but particularly today. Because you see, for almost 8 years, you learned the culture of the company, you visited the company, you're solving company's problem. So there's a lot of this startup learning process. It's already been done. So when you hire somebody, it's almost immediate that they can start working on the company without this initial setup business. So yeah.
That's really great.
Oh yeah. This is a world experience for our students.
Mm-hmm. What are some of the top attributes you'd say that your students typically have? The leaders or one particular, but generally students.
Okay.
What draws them to work with the project?
Well, again, it's teamwork, which is valued extremely highly in today's world. You know, just the me, I, mine world is coming to an end, I think, somewhat. And that's been the great motto of this country for a long time. But now we're changing it to us, we, together. And teamwork really, as I said, you know, the performance of the team is much bigger than the individual's performances, because, you know, there's a lot of add-ons that we get from each other being together. If the team is good, if the chemistry is good, and you will see that there's an enormous amount of delivery by the team that any individual cannot have done that. So one great advantage of the IPPD program is learn how to operate in a team environment. Understand the team dynamics. You know, it's just forming, norming, storming, blah, blah. You know, there are 4 phases of team development. So, you know, I lived through each one of them in the 30-plus projects. They lived through it. They realized that, yeah, that's how the teams are formed and performed. At the end, you want to reach the performing phase. But those other phases in between are the transition phases. So the faster the first 3 phases are, the faster you reach to the performing phase. And that means that much more you can get from that team. So my job as a coach is to guide them, coach them to get to that performing phase as fast as they can. And I leave them alone, but yet, you know, under control. So if I see some of those issues emerging, quickly we try to solve the problem, because I want to get there as fast as possible. So that all that remaining time is going to be a great teamwork. So that's one thing that definitely is a big plus, and it's hard to learn in a regular classroom environment. And number 2, they learn 2 things: writing and talking, or presentations. They write reports on a regular basis, almost weekly basis, what we call deliverables. Students learn to deliver just the right amount of thing at the right time. No excess yaps, just the right information and right material when it's needed. And they have to go and present that. Again, whatever it is that week or the previous week that they had to design and improve or do, now they have to come up to class and present that in less than 5 minutes or 4 minutes or 3 minutes, like an elevator talk. So they have to be very economical in the words they select, in the sentences they select, in the graphics they select, and the number of pages that they're going to display on their PowerPoint. There's no luxury of extra pages. Same thing goes in system-level design presentations as well as the final presentations. Each team has 15 minutes. Everything. They have to tell the story from beginning to the end in 15 minutes, including questions and answers. So they learn now how to really become a great speakers. And also, we ask them to write a report at the end, which is really a professionally designed and developed report. And these are the extreme values that we add on to our students. Mm-hmm. And also, of course, as I said, systematic view of looking at design and development process, the IPPD process. That's what we teach them. How one either improves an existing product or designs a brand new product from just an idea. That is a step-by-step systematic procedure that one has to follow. And if you do it that way, time to design and develop and to market gets shorter and shorter. Because we're living in a competitive world. It's such a competitive world that one step earlier introduction, or 1 day earlier, or 1 month earlier of that new product into the market may mean millions and billions, and 1 week late may mean millions and billions lost. Think about the competition between Apple and what is the other company now? They're competing with each other.
Windows?
Samsung.
Oh, okay.
Okay.
Yeah.
So you see how they're competing with each other? What other functionalities they can put into their product and put it into the market. If you're late, you're too late. Or, somebody already gets the patent on that and you're too late. So we're talking about squeezing this time to develop and design and produce shorter and shorter and shorter. And that means that process, doing it right the first time, is so important. You don't have the luxury to make mistakes and then try to correct the mistakes later. So you have to consider it in such a way that your design is the right one the first time. And try to overlap some of those phases of product development in such a way that the overall time it takes to design and develop and produce is shortened and shortened. And that gives you a longer life cycle on your product and therefore longer return when your sales are. So all of that is taught through this IPPD program. So these are something it's difficult to teach students unless they get their hands on.
Mm-hmm. Okay. And what are some of the top attributes for coaches who usually get involved?
Top attributes?
Yeah. What kind of personality?
I missed the last part of the sentence.
Yeah, of coaches who get involved. Typically, what kind of personality do they have? What do they get out of the program? That kind of thing.
See, although we don't use personalities and characteristics of individuals in matching students to the project, because remember, we're giving a priority to their first choice and all that. Mm-hmm. So sometimes we may have introverts, extroverts, and remember different personalities. Yeah. So you want to have the right distribution of those people in a team. We may not be able to do that because of giving them the preference on their first choices and all that. And besides that, you have to give them another test to find out whether they're introvert, extrovert, or whatever they are. So we discover who they are after the team is formed. But we quickly discover that. And, accordingly then, we try to treat them to do the best or to give the best to the team and to the project based on their characteristics. So that's something, we recognize them quickly. Who's introvert, who's extrovert, but who's hard worker, who's not, and who's just a big mouth, but not the one that delivers goodies. Eventually, you become an expert of human beings, actually, and students. You can recognize them very quickly. Which one is a big mouth, talking a lot but not delivering anything at all, versus which one is the one that's silent, but hey, anything assigned and given, delivered right away. So it's just part of that human relationship. So, we try to maintain, depending upon how perfectly matched or mismatched the team members are, and we try to at least sell the difference somewhat by contributing and being sort of a judge and a player at the same time on the team.
Okay. So what sort of thing will draw a coach to get involved with IPPD?
Will drive the coach, did you say?
To get involved, yeah. What would initially drive a professor to start getting involved in IPPD? Like the teamwork aspect
I don't know, since I was from the beginning.
Mentioned?
Well, yeah. I'm more on a hands-on engineer with all my degrees in engineering. So it excites me to see new things created, designed, developed, and executed, and implemented.
The whole way, yeah.
And of course, I can focus more on my own field, industrial engineering, production, manufacturing, and things like that. But of course, the other professors, I'm sure, they're also part of this excitement of really being able to physically produce something and see the results of it and see that the students get their hands on this product, design, develop it themselves, and then have that fun part of it. So to me, again, from my profession point of view, as an industrial engineer, it has to be hands-on. I mean, you can teach certain things theoretically and all that, mathematics involved, et cetera, but when push comes to shove, you really have to physically touch, do, and practice it. Mm-hmm. And the only way that you can really have a good deal of that is through this IPPD program, because our students then suddenly realize that, hey, this is real. This is not one of those, one-paragraph problems at the end of each chapter that solve this. Yeah, that's great. You know how it's going to be solved. It could be solved in one page probably, or less than one page, depending upon how the problem is. But now we're talking about an 8-month affair to solve one problem that they submitted us. Now that's problem, not the ones in the back of the book. I don't mean to degrade, of course, the importance and value of the books. They are needed to be able to solve these 8-month problems. So just hand-on is got to be important for every engineer, not only for industrial engineers, but all the engineers in any college, actually, any engineering college. They really have to flourish this IPPD program. There are some similar programs at other universities, of course, through this Succeed Coalition. The name of the coalition was Succeed, SUCCEED, Southeastern Universities and Colleges Engineering Education System, or something like that. I'm sorry if I'm mistaken, but it's very close to it.
Yeah.
So that was that coalition, Succeed Coalition, and that's what the NSF started sponsoring, project from the Succeed Coalition. So the need is there, absolutely, and those who are really up on that bandwagon and developed similar programs like IPPDs are really the winners. And those that fell behind, and they fell behind quite a bit then. Because remember, we've been doing this for almost 20 years now, 20 years actually. And if you're just starting it, you're 20 years behind in improving your engineering education. I'm glad that we're one of the leaders in this field.
Right. So if you could say one thing to the IPPD community and to future engineers about the program, what would it be?
To the students?
Yeah.
Hey, don't miss this opportunity. I know that probably some of your friends that's gone through IPPD will say, oh man, they keep you busy, there are so many things to do. Take your senior design project, get the heck out of there. Don't do it. Take the IPPD. Yes, it's tough. Yes, it requires the energy and time and effort. But what the value add is to your resume, to your background, is enormous. And chances are you may even be hired by that company who gave you the project. And you cannot gain this experience anywhere else. So please take that opportunity. Be part of the IPPD family.
That sounds good. Yeah. So if you could describe the IPPD program in one word, how would you do it?
Awesome.
Okay. That's great.
Awesome.
That's great. All right. Those are all
that's
my
it?
Questions. They are.
Oh, thank you. That's great.
Yes, that's the interview.
All
are there
right.
any
Yay.
concluding thoughts that
Go
you have?
IPPD.
Okay. Perfect.
Ooh.